All right, folks, for our notes today, we started in Schoology. We clicked the parent function graph exploration. And then in that exploration, we started to look and see what the effects of A, H, and K are on a graph. I want to point out that you recognize this shape as a parabola, right? It's a quadratic, but the function looks different. The equation looks different than what we did when we did regression. Remember we did ax squared plus bx plus c? This is just a different format for a quadratic equation. You can put them in different formats. This one's called the vertex form because the vertex of your parabola will show up in the h and the k values. And we'll see that a little bit more soon. So most of you guys noticed that when you made the a value bigger, what happened to the graph? The a value got bigger, the graph got what? Yeah, in like a skinny way, right? The graph got kind of skinnier. So a lot of you noticed that, but I really liked the way Philip wrote it. No. Yeah, Philip. Okay. Can you tell me what you wrote? You said it gets faster. So do you see how the point goes up more quickly? Like right here. Here's your parent, right? It's going up, but all of a sudden it's going up more quickly. That's because the graph is getting taller. So you guys are right in noticing that it's getting skinnier. However, I want you to add to that, if you wrote skinnier / taller. Okay, the graph is being pulled up. That's what makes that effect of making it skinnier. Okay? I'm going to write that on my paper too, but skinnier / taller. For the h, when the h gets bigger, you notice it moved to which direction? Right. To the right. And then when the k got bigger, it moved? For the k, right? For the k, it moved up. So there's a few things to write down. You hopefully went on to the next screen and noticed that these same things happen. Look what happens with the a. See how it gets taller? And then it gets shorter? And what happens when a is negative? Yeah, so it reflects when a is negative. You see that? Okay? And then the h still moves you left and right, and the k still moves you up and down. Looking at the rational, it's kind of interesting to see, like what happens is your whole asymptote moves over left and right. Your whole asymptote moves up and down. I always do that. And with your a value, you can get more stretched out, less stretched out, or if your a is negative, look, it reflects also. All right. So some of you hopefully got to these screens where you wrote, but we're going to write on our paper now. So I'm going to open up IPvo so that you can see my paper. Okay. So look at what you wrote and make sure that you have this information included. When A gets bigger, your graph gets taller. Graph gets taller. If you wrote skinnier, you don't have to get rid of that, but I want you to write skinnier / taller, okay? Now, when A is a decimal between 0 and 1, your graph is going to get wider and shorter, okay? So here's how I'm going to write that. If A is between 0 and 1, that's going to be a decimal like 0.6 or 0.2. The graph gets shorter and wider. And then you notice that when A was negative, your whole graph reflected. If A is negative, the graph reflects. All right, when you change H, so the H was the one that was moving us left and right. So when H gets bigger, you move right. And if h gets smaller, you move left. And that makes sense, right? And then your k was shifting you up and down. So when k gets bigger, you move up. And k gets smaller, move down. Okay. Here's your quadratic function. We're reviewing some of the graph characteristics here. So your domain is all real numbers, which you can also write as negative infinity to infinity. Your range is y is greater than or equal to 0, which can also be written as 0 to infinity. It has an absolute minimum. It has an x-intercept and y-intercept at the same point. This one is decreasing, and then it's increasing. And this is what the equation looks like. You saw this in Desmos when we were looking at it. Your square root function, it's going to have an endpoint here and then an arrow. So again, you can write your domain and range this way, or you can write it in interval notation. It does have an absolute minimum, and it's increasing. The parent function is increasing always. And then here's your parent for rational function, and I want you to add in your asymptotes. Norm Banks, can you please add in your asymptotes? Right here. Okay? So this is really the easiest way to write your domain and range. It's basically all the numbers except not 0. But if I wanted to write that in interval notation, it would be negative infinity, comma 0, u, 0, comma infinity, like that. And then at the bottom, we have the equations. Now, we're going to need these equations because we're going to be graphing, we're going to be writing equations using these formats today. All right, if a is less than 0, so that would be, like, for example, a is negative 1. Okay? You're going to have a reflection over the x-axis. And so when we reflect it, we want to reflect actual points. It's not just a sketch. So I have some points on this parabola. Okay, do you see how I made 5 points at these exact places? Negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. I'm going to reflect these exact points. So to reflect it, 0, 0 stays in the same exact place. Negative 1, 1, it reflects down here. So you see how it's going to reflect across the x-axis? 1, 1 reflects across the x-axis here. And then negative 2, 4, it needs to go 4 down, and I don't quite have 4 down. So I'm just going to estimate that it would be about there. And then 2, 4, it needs to go down 4. And then this is what we're graphing. So you want to show those points to show that you graphed exactly and you didn't just estimate where it goes. So I moved those 4 points, I reflected them across the x-axis. All right, if the absolute value of a is greater than 1, then you're going to have, it's called a vertical stretch. By a factor of 2. And a vertical stretch is also an example of a dilation. You know, sometimes if you go to the eye doctor, they dilate your eyes and it makes your pupils really big. So a dilation is a vertical stretch, because also a dilation is a vertical compression. And so using that word dilation can make your life a little bit simpler. So when you dilate by a factor of 2, here's what happens. Multiply your y values by 2. Okay, so 0 times 2 is still 0. 1 times 2 is 2. 4 times 2 is 8. And I'm only getting up to 7, so I'm going to have to estimate 8 to be up here. This side is going to be the same thing. I have a y value of 1. 1 times 2 is 2. A y value of 4. 4 times 2 is 8. And again, I have to estimate it up here. So here's how my graph gets taller and skinnier. Okay, I'm going to pause there because I see some of you still writing. If this one, y equals 2x squared, gets twice as tall, y equals 1/2 x squared is going to get half as tall, right? So it's going to get shorter. We call this a vertical compression. By a factor of 1/2. Vertical compression can also be called dilation. So you can use the word dilation for both vertical stretch and vertical compression. All right, now all of our y values will be half of what they were before. So multiply y values by 1/2. Okay, so half of 0 is still 0. Half of 1 is 1/2. And half of 4 is 2. Half of 1 is 1/2. And half of 4 is 2. So you notice it gets shorter and it gets wider. All right, you guys okay if I turn the page? All right, so when h is greater than 0, we're going to translate it. So let's see, h is greater than 0, so h is 2 here. We're going to translate it to the right. Now, h is greater than 0, but you see a minus here. Remember that the minus is part of the equation. I'm going to show you real quick. I'll come back to this. Okay, you see how the minus is part of the equation? So the h is actually a positive 2 here. Okay? It says x minus 2, and people get confused because they want to go left. But the minus comes from the equation, so we actually go right. Okay, so we add 2 to the x values. And that moves you right to. So 0 plus 2 is 2. 1 plus 2 is 3. Negative 1 plus 2 is 1. This one moves right 2. This one moves right 2. So you see how I moved each of the points right 2, and then I'm going to connect them with a parabola. Oops, just realized that I didn't record any of that. I'm just going to say it real quick because I forgot to record it. So the k plus 3 shifted all your points up 3. And then when your k was a negative 3, all the points shifted down 3.